In this session, I'm going to be taking you through a demonstration of the Datactics self-service data quality platform, and I will be covering the following 4 use cases: data governance initiatives, master data management, operational and transactional data quality, and AI and machine learning. Datactics is an award-winning data quality and matching platform. We support our clients as part of a data governance or data management program by providing robust data quality measurement and remediation. By using AI and machine learning techniques, we were able to augment and enhance our platform by reducing the manual effort associated with various parts of the process. The first component of our self-service data quality platform is Flow Designer. Flow Designer is a low-code profiling and rules studio. Throughout the demonstration of this component, I hope to address the critical capabilities of profiling and usability by non-technical business users, as defined in the data governance use case, matching, as defined by the master data management and AI machine learning use case, and also the critical capabilities of parsing, standardization, and cleansing covered in both the operational and transactional data quality and AI and machine learning use cases. Our platform is configured for the end user or subject matter expert. We are an agile offering with accelerators to help our clients rapidly implement data quality rules and solutions. Our self-service data quality platform is designed with the non-technical end user in mind, whether that's a data management team, data analysts, business users, or a data quality author. Users do not need to have any programming experience whatsoever to be able to rapidly configure data quality rules using the out-of-the-box logic built into the tool. As you can see, Flow Designer is made up of graphs and nodes, and you can see a list of the operations available to the user down the left-hand side, covering everything from analyzing, re-engineering, and matching their data. Each of these operations has an out-of-the-box functionality available to the user to empower them to rapidly configure and deploy their own data quality rules. So the first thing I would like to show you is how we can profile, parse, cleanse, and standardize our data sets using the Flow Designer platform. As you can see, we have a file imported containing name, date of birth, and address information. As soon as we import our file, we have profiling that occurs automated upon ingestion. And you can see 3 tabs of these profiles below. The first being a graphics profile, showing you the composition of your record, whether it's only alpha, only numeric, other filled, empty, or white space. We then also have a data profile, breaking down each column, tell you the number of rows, how many are filled and with what, whether that's white space, alpha, numeric, or punctuation, how many are empty, the longest and shortest characters, as well as the minimum, maximum, and average mean values. We also get a character profile upon ingestion, which breaks down each column and tells you how many of each character is occurring within that column. Other than this, we also have a profiling operation that we can use. Here we simply select which column we wish to profile. We can select a frequency profile and a pattern profile, which covers number of records, field lengths, and alphanumeric groupings. And then we get the results of that below. Frequency profiles allow us to analyze how many unique values we have within a column, or discrete values. And then our pattern profile allows us to see the formatting of each column, which can empower a user, such as this instance, to go away and build a data quality rule for standardizing their date of birth column format. Now I would like to show you how a user can parse and cleanse address elements out of a single column into their individual elements. So here we can see an address line containing street information, city information, and a postcode. The first thing we've done is we've used one of our out-of-the-box functionalities to parse out a UK postcode. A user has the ability to extract data elements from a column using a range of built-in functions, or they can also configure their own. As you can see here, we've used our out-of-the-box UK postcode parsing. And you can see the results of that we now have a column containing all of our postcodes. The next thing we did was then extract our building numbers. This is another out-of-the-box parsing ability. And you can see the results of this again. We're not able to only parse out numeric values, but also where apartment numbers have occurred, like 5A being shown here. The next thing we did was then extract our city. The extraction operation also covers the ability to match against a pre-packaged knowledge base of terms. In this case, that was one that contained UK city names. Then, as you can see, what we have left is a column containing two address line fields, whether that's address line 1 and an address line 2 that would be separated by a comma. FlowDesigner also has the ability to split text fields based on delimiters. And so here, all we're doing is splitting that column out based on a split action of comma, and we're splitting it to 3 columns. And we can see the results of this below. We now have a column containing our address line 1 information and our address line 2 information. This product ships with a range of out-of-the-box cleansing operations that can be applied to your data to standardize your values. As we can see here, we have commas occurring at the end of this string on some occasions. So the next thing we want to do is clean out that punctuation. You can see some of the out-of-the-box cleansing functionality available to the user here. As we standardize out the punctuation, you can see we no longer have that comma occurring on this column. The last step then was simply to arrange these columns into our new data file for exporting. We can also rename our column names using the Options tab. And we can see the results of this below. We now have an address number column, address line 1, address line 2, city, and postcode. Now that we have profiled, parsed, cleansed, and standardized our data, I will show you how we can build out a data quality rule for postcode validation against an external trusted source of data. In this case, we are going to be using the postal address file. The aim of this is to show how we are able to match and link different sources of data. As we follow through, this is a standard workflow for any self-service data quality rule. And so the first thing we do is we tag our imported source data with some metadata. And you can see each of these records have been tagged with a row ID and a rule ID to better identify these records later in the process. We then have 2 branches, one which simply counts the number of records that we have checked. This facilitates us to calculate out a data quality score for this rule later in the process. The second branch then performs the actual postcode validation. The first thing we do with both of our files is clean out any spaces that are occurring in our postcode. So again, we're simply selecting our postcode column and selecting a cleansing operation to remove any spaces. This will facilitate a more accurate match to happen. Then the next thing we want to do is search within our source dataset for where our postcodes are populated. So here we have a search operation. We have selected our postcode column and we are doing a search action looking for populated records. And we can see the results of this here. We now have all of our records brought through that have a valid postcode, populated postcode against them. The next thing we do with both of our files is simply sort on our postcode, and this helps quicken up the match process. Then all we do is simply match our two postcodes together. So we have selected from our source system our clean postcode column, and then we've also selected from our external trusted source their cleaned postcode column. Here we are simply selecting an exact match action. However, Datactics ships with out-of-the-box fuzzy matching capabilities. As you can see here, we have tight subset matching, standard subset matching, and phonetic soundex matching as well. Each of these comes with a different level of error tolerance. Then all we do is we simply select to bring through only our unmatched records from our source dataset, and you can see we have identified 4 records that have a postcode that does not exist within our postal address file. Now at this stage, all we have to do is arrange our columns to decide which columns we want to bring through into an issue remediation stage. This decides how much additional information you are going to supply to the data stewards to facilitate them in going away and investigating this record to propose a fix. Once we've done that, all we do is export our results and deploy this project into our data quality manager. However, there's also the option at this point to match our unmatched postcodes back to our postal address file to get a suggested postcode match from our trusted address file. So here, all we've done is we've matched our results back to our postal address file on city and our address line 1, and we've allowed slight error tolerance in both of these matches. And you can see the results of this here. We successfully matched against our postal address file based on the city and the address line 1, and we now have a postal address suggestion for our postcode. This again simply facilitates the data stewards in their investigation of what the correct postcode for each of these records should be, and speeds up that issue remediation phase. Once we have exported our file, we simply deploy our projects directly to our data quality manager. At this point, we can also use a merge operation if we wish. As you can see here, we have a merge operation that can be performed if we wanted to combine multiple matches. It allows rules to be specified at a column level, which will allow information from several records to be merged and stored as a single composite record. Now we're going to move in to our data quality manager. Once rules are deployed into the data quality manager, this is our workflow, automation, and connectivity hub. Data quality manager allows for a data governance team to connect to data sources, configure automated workflows, outputs, and schedule the entire data quality process. During the demonstration of this component, I hope to cover critical capabilities such as workflow management and usability for data governance teams, as covered by the data governance use case, as well as critical capabilities such as workflow management and multi-domain support, as covered by both master data management and operational and transactional data quality use cases, and also scalability and performance, as covered within the operational and transactional data quality and AI and machine learning use cases. Datactics offers a robust solution for data quality monitoring and remediation, but the workflow is also highly configurable and so can be updated to facilitate your business processes. The platform is completely data agnostic and can be applied to any data domain, for example, entity data, financial data, instrument, citizen, product, policing data also. You can see examples of some of these data domains here. We have domain expertise in helping clients in all of these areas, and there are rules and logic built out of the box that can be applied to these domains. However, our domain expertise is within the financial sector, and for this reason, a lot of the logic built into the tool is directly related to the financial sector. For example, we have a whole range of rules out of the box directly related to the Financial Services Compensation Scheme, FSCS. There are many components to Data Quality Manager. One worth noting is this rule dictionary. This is where a user would go to populate out and define the rules that they are going to build and configure. They can do this either by populating out this form, or we can also pull this in from data governance or data cataloging systems and populate this automatically from those systems. Then we have our solutions. This is where we run the entire data quality process. Each of these blocks contains a piece of logic that will go out to the source and measure their data using the definitions that we've defined in our rule dictionary table, and also the Flow Designer configuration for our data quality rule. Once you've ran the data quality process, the results of this are wrote to a database, and it allows us to run scheduling processes. We can schedule this to run weekly, daily at a certain time, or also trigger it on file creation and streaming. Data Quality Manager also comes with a whole range of microservices, such as file compression, decompression. It can run external applications, and also has toolset items for integration with AWS and Azure, HTTP and JDBC connectors, and also CSV conversion capabilities from RDF, JSON, etc. If you wish to update this to accommodate your business process, those range of toolset items can be used to do this in line with the data governance and master data management use cases. For example, there can be notifications made to data stewards and other key business side stakeholders through our email microservice, or also through using a REST API to send Slack notifications to relevant parties. Now I would like to cover some of the scalability and performance notes on Data Quality Manager. Data Quality Manager is the core rule execution platform. And can scale both vertically by adding more CPUs and RAM, and horizontally by using more nodes, or Data Quality Manager instances. To scale vertically, data operations in Data Quality Manager can be run in parallel in a single solution to take advantage of multi-threading, as can be seen here. Here we have an execution thread count of 7, and so all of these operations will be run in parallel. To simplify horizontal scaling, Data Quality Manager can run in master, cache, and slave nodes, as you can see here, where the data quality rule configuration can be propagated from the master Data Quality Manager solutions from the master data quality manager down to multiple slave worker nodes. For API-driven use cases, this allows the implementation of a load balancer to share incoming requests between worker nodes, or for scheduled batch jobs, data quality manager solutions can be configured to execute and farm out work amongst slave nodes. So, by being able to parallelize these operations within the data quality manager, we can deliver suitable throughput and response times to satisfy performance SLAs. Once you have ran your data quality process, the results of this then get surfaced into our dashboarding tool. Throughout the demonstration of this, I hope to cover the visualization critical capability outlined in the data governance use case. Datactics provides customized off-the-shelf templates for all major visualization tools, such as QuickView, Power BI, Tableau, and others. The dashboard provides an interactive analytical workflow and visual output of the statistical analysis to help business and IT users identify, understand, and monitor their data quality issues and discover patterns and trends over time. Business users and data stewards can access specific dashboards for their domain or area of responsibility. Here you can see an example of our Power BI overview page for the data quality platform. There are many visual attributes displayed here of the typical things that our clients like to measure. However, we hold a lot more information behind the scenes, and Datactics supports an open metadata model. So you are able to define what business contexts are valuable to you and then present those visuals onto your dashboard. You can then drill down to identify your failing records and perform root cause analysis. As you can see here, we have visuals representing the failing data quality checks by data owner, data type, some general statistics, data quality checks by dimension, and a remediation progress visual here. So if I was logged in as a data steward, this visual represents to me how many records currently assigned to me have been resolved, are currently unresolved, or pending in real time. Then on the right hand side, we have a representation of the data quality score. This shows you how the data quality in my domain is performing over time. Perhaps showing a dip here where a new source system has come in and our data quality score has dropped dramatically down. But as well as that, showing as I do any issue remediation and resolve records, how that data quality score can trend up over time. Then we have our data quality score by source system. So for example, if we wanted to look at our data assigned to our corporate data owner, we can see what source systems that data is coming from. Then we can also see the DQ score by regulation here. So a lot of our clients like to use our platform to see if they are passing certain regulations, and that's really what our rules are tailor-made to do. So moving into our SSDQ define page, we get presented with a rule dictionary, which shows us a list of rules that we have built out and defined and ran against our source systems. We can then select one of our rules and see a summary table of all the breaks that have occurred. So you can see here, we have looked into our postcode validation rule and we can see the 4 records that have broken within this rule. We can then drill down into a specific record, as you can see here, and we will get this table highlighting to us the actual broken record, which is this postcode. And then we are able to click this link through, which will open our data quality clinic. The data quality clinic is where data stewards can perform issue remediation. Here they will receive data quality breaks in their queue. They are able to connect either to a specific issue from the dashboard drill down, as we have done here, or they can log directly in to their account and see all the breaks that are currently assigned to them. Throughout the demonstration of this component, I hope to cover the use cases of data governance, master data management, operational and transactional data quality in respect to the critical capability of workflow management. So as you can see here, this opens a very rich ticket containing all the information related to our broken postcode record. From here, as a data steward, I am then able to propose a change to this record and what I think the postcode correction should be. So I'm able to update and correct these DQ issues. I can give it a break type and assign it a root cause as well. I can then set this record to resolve and save my changes. From here, the resolution can be returned to the source system via ticketing, or we can also, if a client doesn't have a tolerance for that kind of process, have 4 eyes validation. By doing this, I'm able to set this record to pending resolved, assign it to a different user or person who would be in charge, who would have the permissions to update this record at the source themselves. This would come with a full audit trail of where this record has moved throughout the data quality clinic and what changes have been made and by who. Now I'm going to talk about scalability and performance in relation to the data quality clinic. So Data Quality Clinic is where users come to review and fix their broken data. Unlike Data Quality Manager, it is not a computing-intensive application. It provides a thin UI and API layer into the Data Quality Clinic database, where the bulk of the processing is done. It's able to scale horizontally simply by adding more Data Quality Clinic web application servers. It is also a stateless web application, and as clusters of Data Quality Clinic web application servers can all talk to the same DQC database. Each web application can handle approximately 20 users per application depending on the usage, which is generally 1 per logical DQC application per department. Alternatively, a cluster of DQC web applications can be placed behind a load balancer to facilitate the usage by a large number of users. Now, I just want to talk about some performance and scalability benchmarks. So data processing performance, whether that's data quality measurement, cleansing, or matching, is highly dependent on the data and the nature of the data quality checks or match algorithms involved, including parameters such as the number of records, the number of fields, the complexity of the data quality checks, and how the solution is engineered regarding the degree of parallelization across threads. These are some real-world performance benchmarks for 3 very different use cases, running on a range of computing hardware. The first use case is an implementation of self-service data quality measurement at a Tier 1 bank in New York, with an overnight batch job performing 3 billion data quality checks in approximately 3 hours on a single mid-range on-premise server. The second use case is an overnight GDPR batch job to link 1.4 million messy customer records from 3 disparate silos in different formats, standardizing and fuzzy matching on name, address, and other PII fields. This was implemented in an AWS cloud infrastructure on a comparatively low-end EC2 instance and still achieved acceptable performance. The third use case uses the same data and infrastructure as our previous one, but this time it was simulating a GDPR case management, where we search for a single person across the 3 disparate data silos via a REST API call, and we still achieved acceptable performance to power a case management web application. Thank you.